Surgitag Lorraine was doing a very brief and very celebratory prayer, having everybody here. We're just going to do the Latin Glory Be. We'll be doing that for this week, so it'll be very low key. In nomine Patris et Filii et Spiritus Sancti. Amen. Gloria Patri et Filio et Spiritui Sancto. Sic ut erat in principio et nunc et semper et in saecula saeculorum. Amen. In nomine Patris et Filii et Spiritus Sancti.
We use this one.
The exams are yours to look over. This is kind of unusual, though. You are actually able to keep those. I make new versions every year anyway, so it doesn't make a lot of difference. If there are any questions you have going through there, polite me after class. For now, check out your notes, please. We're plunging into chapter
Can we just go through it?
12, halfway through. Really don't have time, sorry. I can probably, well, that's not the right book. If anybody really needs me to, I could probably whip up a video stepping through piece by piece what the answers are. But let me know if that's the case. Is this thing running? Oh, good. All right. When last we checked, we had just handled 12 E's in Egbert. And I want to talk a bit about restrictions.
Not real restrictions.
On radicals. Now, for the past chapter or so, we've played with restrictions as being things in the denominator where you can't have the bottom equal to 0, which is still true. You can never divide by 0. However, there's a new type of restriction we're going to have to deal with in radicals. For example, here's a review. If I give you this formula, x plus 7 over, and let's see if I can do this, x squared plus 9x plus 14. I would like to know the restrictions. You don't have to simplify the original problem unless you want to, but I do need to know the restrictions. What values of x are forbidden, cannot be used? How would you go about finding them? Yeah.
0.
What about 0?
Oh wait, never mind.
Okay.
Never mind.
Oh, I see. Nate, is where to start? Right here. Starts on that? That's one type. Unfoil is one of the 7 types of factoring. Bingo. So you get a factor at the bottom. Does it factor, by the way? Into what? Yeah, go. X plus 2, x plus 7. Does this thing simplify, by the way? Again, you didn't have to do it. Yeah.
1 over x plus 2.
Right. The x plus 7's cancel. Just be careful. It's 1 over x plus 2, which is your final reduction. That was in English. Final, I was going to say your final solution reduction. And I tried to do them both together. It didn't work. So reduct. Welcome to my life. This is the reduction. Yeah. But I need to know the restrictions. Go.
Negative 0.
That's definitely true. X cannot be negative 2. However, there is one more.
No more. X cannot be negative 7.
Why not? Yes. Why not? Anybody, go.
Because x plus 7 is still the denominator.
Right. It was at least for a few seconds it was in there. There is a rule that says in any, it's kind of like a life lesson too. If you die at the beginning of something, you're just as dead as if you die at the end of it. So if something, sorry about the violent metaphor, but if this thing blows up in step 1, you're in just as many pieces as if it blew up in step 2 or step 3. So, let's say, I'm about to take a drive across the country. Boom! And then, end of drive. Now, let's just say you actually get to Iowa before your car blows up. You're still dead. So, if the thing blows up here, or here, or here, that's still a problem. People say, well, I don't see any X plus 7 on the bottom. You're right, you don't. That means it already blew up. So if somebody flew in, I wanted to say blew up and plugged in.
Sounds like shaded.
But, yeah, I know. But, does everybody see, like, if anything is ever in the bottom, you have to forbid it from being 0. Whether it's in the first stage, second, third, fourth, fifth, or how many stages there are, make sure you forbid it from being 0. So you have 2 restrictions here. X is not -2, and X is not -7. Does that make sense? Now, a little bit of a weird spin. Let me give you a list of illegal operations. In math. I'm not talking medicine. Let's not go there. First, dividing by what? Yeah, dividing by 0. That's the one we've been playing with a lot. The second thing, if you square root any what? What kind of number you are not allowed to square root? Or it'll cause an error on the calculator. Max, try this one. What kind of number can you not square root? You can actually square root a decimal. It'll usually be a horrible answer, but it's legal. It's just icky. Go.
Negative?
Negatives, correct. You cannot square root a negative number. Why not? Like, what's wrong with taking the square root of -4? Ricky? True, and it's even worse than that. How then? Yeah, they're basically saying that something squared is equal to -4. And like, what's the something? Beats me. Because if you try 2, that doesn't work. It's +4. What if you try -2? What's -2 times -2? Go. It's also +4. So no matter which way you slice it, this is impossible. There's no real number that does that. So you cannot square root of negative numbers, as far as we know. That's an illegal operation. If you try it on a basic calculator, it's going to give you an error. The third, which I actually haven't talked about much, which is kind of amusing, if you're in the mood for that sort of thing. 0 to the 0 power. This is, did I talk about this yet? I don't think I did.
Maybe briefly,
You?
when we were talking about how powers work.
Oh, right. Let me show you just real fast. Does somebody happen to remember, like, to the 0 power, what kind of answer do you get? Yeah.
1.
You get the answer 1. Correct. So if I get like 3 to the 0 is 1, 2 to the 0 is 1, 1 to the 0 is 1. So theoretically, 0 to the 0 should be 1. Make sense? Yeah.
Yeah, there's always 0. There's nothing to divide it by to get 1.
True. First of all, this is a little strange. Try this. What's 0 to the 3rd power? Anybody? Yeah, 0 times 0 times 0 is 0. What's 0 squared? 0. Oops. What's 0 to the 1st power? So according to this, what should 0 to the 0 be?
0.
Yeah, we've got an issue here.
Yeah.
There is, this is actually called in computer language, this would be called a bug. This would be like there's a hole in the software that they forgot to patch. So they would have to patch something. 0 to the 0 power, if you type it into a calculator, it's an error. This is technically called undefined. In other words, we really don't know what it equals yet. Mathematicians of the world right now are arguing about it as we speak. Apparently not very quickly, because they've been arguing about it for decades. But
Why wouldn't it be 0?
wouldn't it be 0? There is, that it, emotionally speaking and intuitively speaking, this just feels better. 0 to the 0 power is 0.
Oh, wait.
However, 3 to the 0 power, a lot of people would assume that was 0 as well too, because how many 3's multiply together? None. Should be 0. But it turns out it was 1. The real fact, if you remember this, 3 to the 3rd, 3 to the 2nd, 3 to the 1st, 3 to the 0. This is 27, this is 9, this is 3, this is 3 times 3 times 3, and 3 times 3. You divide it by 3 every step down. And if you do that again, just a little bit, yeah.
But you can't divide by 0. That's all.
Correct. You cannot divide by 0, so that's where this formula breaks down. So, and according to this argument, I should get an answer of 1. According to this argument, I should get an answer of 0. These are the two candidates being argued about, whether the answer is 1 or 0. Except there's a teeny weeny slice of people that said, we should just leave it undefined forever.
Yes.
Yes.
I'm one of those.
Yeah.
Yes, I'm one of those.
Yeah.
Because it can't be.
The last time, I mean, they don't invite me to their conferences, so
Wow.
I don't speak French or German or whatever they do, it's in Europe. But they're actually leaning toward this one.
No.
Because more math formulas work when you use that than this. This is more emotionally appealing, but this makes more math formulas work.
But it doesn't make
Some of the
sense.
really complicated math formulas, this makes them happy, and this does not.
But
This causes a division by 0 halfway through it, and this does not. So, they haven't decided yet, obviously, and I'm not sure they will. I think the people who started arguing about this are long dead. So, their grandchildren are still arguing about this stupid thing. But just to be aware, for our purposes, 0 to the 0 power, undefined. Naughty, naughty. Can't do it. Now, why would we bring that up? The 0 to the 0 power is interesting, but I'm more focused on the radical ones.
I have a question. So the 0 to the first power, is that also undefined?
0 to the first power actually is defined. It's 0, it's just 0.
Which is
And 0 squared is 0 times 0, which is 0. So 0 to any power other than 0, you'd be, well, any regular positive power would be fine. You'll get an answer of 0. 0 to a negative power is bad, for reasons I'll talk about later. Probably not today. But here's a quick question for you. Radical action. Go ahead and write that down. My question is, what values of x are legal? We've been talking about what's illegal, but what values could you use without blowing it up? Now remember, I'm not talking about whether the answer is gross or not. There are plenty of numbers you can plug in that'll make the answer a disaster or a decimal, but it's still legal. It still exists. Like the square root is 7.9. I don't know what that is, but it exists. Yeah.
positive numbers?
Positive numbers. What's the lowest you could go and still be safe?
I mean, that's like 1.
1? Could I plug in a half?
Yeah.
Yeah. How about a quarter?
Almost anything above 0.
Could you do 0?
Yeah.
As a matter of fact, yes. What's the square root of 0?
0.
0. It actually does work. It's legal. It's boring. It's legal. Could you do negative 1?
No.
No. How about negative a half?
No.
No. What kind of numbers do you have to avoid? Negative. What can you use? Positives and 0. How do you say that in math? What kind of numbers are, yeah.
No.
I'll give you hints. Use less than, greater than, or greater than equal to, less than equal to. X is greater than or equal to 0. Those are all the legal numbers for this thing. Anything 0 and up is safe. Does that make sense? Everything 0 and up is safe, by the way, don't make sure your math's good. So, this is what's called a restriction. Normally restrictions look like x is not equal to blah, blah, blah. This time I had to use an inequality, in this case a greater than or equal to. I'm restricting x to 0 and above. I'm forbidding it to go to negative, because that causes it to blow up, and that's bad. Does that make sense? So what kind of things can you put into a radical? Is there a name for this? People want to say positive, and I understand why. Technically, 0 is not positive, so it's a little more clunky. Non-negative. That technically includes 0. Because 0 is neutral, it's neither positive nor negative. So non-negative includes 0, so you're safe. Now, let's try something a little more exotic. Let's try this one. Radical x minus 7. I would like to know the restriction. What kind of numbers could you plug in safely? Yeah. 7 is safe. And anything else?
You can't have a negative.
Correct. I can't make this answer negative. 7 looks like it's safe because you're right on the edge. And also?
7 and above.
And above.
Yeah.
In other words, 7 and up. Is there a math way to put that? Like using an inequality? That is. Use the letter x. You could. I'm just saying if you have to, all the x's have to be 7 or above, what's the way to say that in math?
It would be greater than minus.
Or,
Slash under it.
which is greater than or equal to? Greater than or equal to what? You got it. That's the restriction on this problem. X is greater than or equal to 7. Is there a way to know that ahead of time? Now that was a little harder to do because we had to do it in our head. I'm about to give you one that's a bit more challenging. Oh yeah. Nice. Radical 3x plus 11. What's the restriction there? Harder to tell. And I'll tell you right now, a lead number is not a whole number. It's a fraction. This gets to be a bit of a bro pain. Anyone want to take a wild guess? Go.
0 and up?
0 is actually safe.
Wait.
See what I mean? I'm just talking about x.
Oh my gosh. Wait a second.
0 would be safe. Actually, believe it or not, -1 would be safe.
Yeah.
See why? 3 times -1 is -3 plus 11 is 8. Still safe. Something like that.
Negative 3.
Yeah,
Negative 11
-11 and up?
No.
That would be -33. That's actually too far down. Yeah.
Anything,
There we go. This is hard. I'll show you a trick to get it, but yeah. In your head, this is a beast. -3 and up, that's very close. 3 times -3 is -9. Plus 11 is 2. You can go a little lower than -3. What? 3 and 3/4? You're very close.
Negative 3.
It's between -3 and -4. You're correct. What? -3 and 2/3. Now. Yeah, I know. Let me show you what that actually is. Can anybody make a non-mixed number out of this thing? Yeah. Negative something. -11 thirds. Did we see those two numbers in there? See where they might have come from? Now, let me show you the trick for actually getting this. I mean, it's kind of fun to do it by sheer muscle strength. There's a certain my muscles are popping out, and I can just, but there is a technique. Watch this. Here's the technique. In other words, how do you actually get this consistently? Would everybody agree that the stuff inside the radical has to be 0 or bigger? Can't be negative. This, here's how I see it. I actually do this in calculus a lot. It's called the blah method. What do I mean? Pretend you're nearsighted. Pretend you're looking at this and you go, the square root of blah. Pretend you can't even see it. That's actually a useful trick. Because the square root of blah tells me something. Blah has to be greater than or equal to 0. Everybody agree? Because if you agree, whatever you're taking the square root of, it's got to be 0 or above. Negative is bad. Watch what I'm going to do. Now I'm going to get new glasses or something, which I'm probably going to have to do very soon. And here's how I write it. That's the blah. Can you solve that, little algebra people? Good.
Subtract 11.
Okay, let me write it over here. 3x plus 11 greater than or equal to 0. And then subtract 11. Quick question. Does that flip the sign? Do you remember the things that flip the inequality sign, the less than greater than?
No.
Okay, that must have been last year. And it's been like a year and a half.
Yes.
For now, I'll just say no, it does not. So, by the way, don't put equals by mistake. What would these cancel? What are you left with so far?
3x is greater than or equal to -1.
One more step.
And then you divide by 3.
Yes. What do you get?
X is greater than or equal to.
Ding, 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 ding. That's how you get it. That works every time. You think of blah has to be greater than or equal to 0. Then fill in the blah and do the math. Okay? This is not worth writing, but blah. Okay. For the people watching at home, that's affectionately called blah. We actually do this in calculus. It makes one of the relatively complicated steps in calculus quite a bit easier. But to be continued. So let me try the following. Let's see if you really got a handle on this exotic stuff here. I keep doing 3. I'll do 13x just to make it exciting. 13x minus 7 plus 1 over x minus 5. I want to know all. You don't have to solve it. That would be horrible.
Is that all together? My goodness. Is that all under it?
Nope. This is separate.
Oh. I did that.
It's a radical plus a fraction.
Yeah, 13.
I would like you to list all restrictions whatsoever. The old-fashioned type from fractions and the newfangled type from radicals. Oh, that is wrong. So, yeah, go ahead.
One restriction is 5.
Yeah, first of all, x cannot be equal to 5. So there's your old-fashioned restriction. You're half done. Anybody want to attack the other one? Yeah, sorry.
Will you do 13x minus 7 cannot be, can be greater than or equal to 0?
Yeah, blah has to be greater than or equal to 0. Go ahead and solve that for me.
Then you plus 7
Okay.
on both sides.
Okay.
Which,
Sorry, I swooped the 7. It looked weird.
which cancels.
So 13x is greater than or equal to 7. Okay, keep going.
And then divide by 13
Okay.
on both sides.
Just make sure you don't put an equals by mistake. And x is
Equal, is greater than or equal to 7 over 13.
done. Yeah.
So you didn't put the equals in the slash, you would put the,
Greater than or equal to, right. The old-fashioned ones from fractions, where you make the denominator not 0, do the not equals. If you're doing the radical restrictions, it's going to be greater than or equal to or less than or equal to. So let me show you. Can you graph those restrictions? In other words, on a number line, all the legal x's on a number line. Just let me show you what it looks like. It looks a little strange. By the way, could I plug in any old x at all into this thing safely? No. The whole point of having restrictions is that some of these things cause it to blow up. We want to avoid those. One of them in particular is positive 5. I want to skip that. And I need to restrict myself to all the numbers bigger than or equal to what? 7 over 13. Is that bigger or smaller than 1? Smaller. So let's just put a 0 here. Here's a 1. I'm going to put 7 over 13. I'm going to make it a solid dot. Remember that? If we got equals, it's solid. 7 over 13. And which way do I shade it? To the left or to the right? Remember this from last year? No. Graphing things on a number line?
Yeah, we did. We did this. We did it, but I don't remember.
I can give you a crash course in a minute. Don't worry about that. But in your best guess, yeah.
Oh, should we write this down?
That would be awesome, yes. Because I will eventually have you graph these. Yeah.
To the right.
To the right. Yeah. All numbers bigger than 7 over 13. So it's going this way, this way. Just lift it up a little bit so it's not messy. And this is basically the same as shading all the way over. Except there's one number I want you to skip when you get to it. You mentioned it already up here. 5. By the time you get over to 5, I would like you to do this. Skip. And keep going. Just leave a hole there. Perfectly legal. I mean, I don't know if you ever, there was, have you ever heard of the Far Side cartoon?
Yes.
It's this really bizarre, yeah. The Far Side is, it's written by a guy named Gary Larson. It's got really kind of demented cartoons in it, but usually very, very weird. And one of them had this, you know, the machine that you used to paint a stripe down the center of the road. And then there was this, the joke was this is a stripe on the center of the road, and then there was this big, like dotted outline that looks like an elephant, and then it continues in on the other side. It's with the idea that, oops, I ran over an elephant, which is ridiculous, because if you get one of those, it's, anyway, it was one of those visual jokes that, I didn't even think it was all that funny, but it reminds me of this. So like, okay, painting a stripe down the road, oops, I just hit something, but I'll continue on the other side, stripe down the road, stripe down the road. It probably wasn't the most useful metaphor I've ever used. Whatever. Does that make sense? I'm covering all the numbers from 7 over 13 and bigger, but I have to skip number 5 because I promised I would. I said, show me all the numbers that are 7 over 13 or bigger, but skip number 5. Now, why are we worried about it in this chapter? This chapter, you're not even going to have to worry about this thing with shading and such. That's actually next chapter. You don't have to worry about this chapter. It's a flash forward. What do you call it? Foreshadow. There's no such thing as a flash forward. Foreshadowing. That's it. Here's foreshadowing. Premonition. A sneak into the future. Whatever. Now here's something I want you to try. Solve the following. Oh, sorry. Oh, that was dumb. No, sorry.
That was easy.
Hold on. There you go. I had the wrong number down. So radical x minus 2 is equal to 1. I would like you to solve that for me. Any ideas? Yeah, right here. I want to get x by itself. What do you have to get rid of first? I'd love to get rid of the 2, but there's something else I have to get rid of first because it's farther away. Well,
The radical.
The radical.
So you have to do,
how do you get rid of a radical?
you
There's
multiply
actually an
by
extra credit
radical.
problem on the previous test.
You multiply it by radical.
Yeah, kind of, sort of.
Square root.
What? Getting closer. Oh, okay.
Square it,
You square it.
Both sides.
As long as you do the same thing to
Both sides.
both sides.
What would be
Square, square root. Cancel. What do you get here?
x minus 2?
Everybody see that the square and the square root are going to cancel? Because they're opposites?
Mm-hmm.
So it's x minus 2 is equal to what? 1. Okay, so what's up with this?
You add 2,
Add 2 to both sides, what do you get?
3.
X equals 3, congratulations. However,
You have to do restrictions.
there's a catch.
Restrictions.
What restrictions are there in here? Like it.
2
Uh-huh.
and like 2 equal to 2 and
Yeah, so basically x minus 2 has to be bigger than or equal to 0. So add 2 to both sides. And yeah, you're going to get your x is greater than or equal to 2. Is this legal as far as your restriction goes? Yes. Merry Christmas, you got a solution.
Christmas is over.
Not yet.
Well, we're still on the same.
It's
only
only
six.
6,
6,
we have 2
27.
days left.
28, 29, 30, 1, 2, 3, 4. On the 11th day of Christmas, my teacher gave to me a radical with a bunch of something. I can't get it to rhyme.
I told my mother.
Ah! A radical with x equals 3. Thank you. Alright, now, let's try another version.
Okay, come on later.
Solve.
Not the Olympics. It's not. No, not today.
Yeah.
No, today's the 10th.
Today's the 10th day. It's either the 9th or the 10th.
The 10th.
And the Epiphany. The Epiphany's on the 6th.
Oh, I thought you were talking about the day. I was like, it's the fourth.
Let me see. Hang on a second. I hope this works. Oh no, it's gotta be minus. Well, no, I'll leave it. Why not? It's good enough.
So X on the 6th.
29th, 30th, 31st.
31st?
Um,
Oh, right.
oh, I got it.
Never mind.
There. This is actually very close to a test question, extra credit test question.
Nope, what is it?
That was on the previous test.
Oh.
Alright.
I do this now. I hate to.
Believe it or not, this is the same technique as you just did. What's the most annoying part of this problem? Yeah, come on.
That you have to square this.
The radical. Elijah.
You have to square both sides.
You just have to square the entire both sides. Both sides. This is easy. Cancel, cancel. X plus 2. This, on the other hand, is not x squared minus 4 squared. It is what?
X squared plus 4.
Oh, okay.
X squared plus minus 16.
No, minus 8x.
Isn't that
Oh, it's a binomial.
Square the first, double the product, square the last. It's a binomial squared.
Wait.
Yes.
Couldn't you just do 2, write down 2x minus 4s and then cancel?
Yeah, and you should be able to get FOIL them. And then you get this.
You couldn't cancel them?
No, because they're not dividing.
First day.
So, oh, that's an interesting, oh, I see what you're saying. That's a really interesting question. I'll do that in a minute. Oh, math people. Here's your hint. Whenever you're trying to do the zero product property, you gotta get the answer down to what? Hence the name. 0. You gotta get this answer to 0. For the zero product property to work, you have to have an answer of 0. How do you get rid of this? Subtract x as long as you do it to
Both sides.
both sides. Okay, how do you get rid of the 2?
Subtract 2.
Alright. Tell me what you get. Cancel, cancel.
X squared.
What's here?
Oh, 0.
0 equals x squared. What's this?
9.
Yes, minus 9x plus
14.
14. Does that factor?
Yeah.
Yeah. Good.
Why do you apply
X
x then?
minus 2, X minus 7.
Got it. X minus 2, x minus 7.
You can't see.
Yeah, she's right.
Can anybody solve it now? Oh, people who remember your factoring. It's something times something equals 0. Go.
Something times something is 0. Or 2.
This thing. What? Wait, what? Ooh.
2?
That's correct.
X can't not be.
It's x. This is not restrictions. This is
Oh.
solving.
Oh,
So x minus 2 equals 0, or
X minus 7.
x minus 7 equals 0. Remember zero product property? Something times something is 0. Go for it.
2.
Add 2 to both sides. X equals 2. Now over here.
7.
Add 7.
7.
X equals 7. Nice. So, question. What restrictions
You must say,
are in here? Elijah.
2 or greater. Like, 2 or,
Well, x plus 2 has to be bigger than or equal to 0.
yeah, I know, subtract 2 of both.
Subtract 2. So what do you get?
Negative 2.
X has to be bigger than or equal to negative 2. Are both of these safe?
Yeah.
Yes. I do have a surprise for you though.
No.
And I'm afraid it's not. First of all, let me stop there. The only really weird step, you get rid of a radical, we squared both sides. Because square and square root are opposites, they cancel. And remember, square the first, double product, square the last. The one weird step was we had to get the answer down to 0 for the zero product property to work. Zero product property was the end of chapter, what is that one? Chapter 10. That was like in class number 67 or something like that. We had something times something equals 0. If a number times another number is 0, does it make sense that one of the two numbers had to be 0? Because if you multiply things and get 0, something killed your answer. So it either had to be this thing equal to 0 or this thing equal to 0. Write that, and that's all. It looks like everything's wonderful. We have 2 solutions. Yeehaw. Plug in. Let me show you the original formula. Right before we went on break. Well, right before we did the exam. Right before we went on break, I had notes about what's something called an unfair fight. Squares cancel square roots. Yeah, I don't remember what names I used. Biff and Guido, great. Why do I always do the Sicilian, Italian people? But, which one is bigger? Which one is stronger, I should ask? A radical? Which one is stronger? Hold on. A square root or a radical? Yeah. Square root. Why do you say that?
Because it's a positive and negative.
Right. A square root, this is twice as strong as this. Because there's 2 answers, this only has 1. So when you square something, a square root are perfectly matched. But if you take a radical and square root it, this gets crushed. A square is strong enough to crush a square root. So a poor little radical is going to get pasted. Like, okay, well, okay, let's make sure nobody dies. But here, all right, Biff and Guido. Okay, Biff is the square. Guido is the square root. Biff walks up to Guido. Guido walks up to Biff. Hey, you're pretty strong. No, that's a Russian accent. Okay, fine. Let's say Biff is Russian. Biff is Russian, Guido is Italian. Biff walks up and says, hey, you look pretty strong. That's just... Hey, I think you're pretty muscular yourself, huh?
It's going.
And you want to fight? Yeah, I'm gonna send you back to your mama crying, yeah. So, Biff, Guido, they're equally strong. Pow, 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 pow. At the end of the day, the both say, how about we call it truce?
Oh, that's not happening.
Yeah, just for today, just ow. Just for today, okay, fine. And they're pretty evenly matched. They'll walk away, everything's fine. Now,
Sounds like Groove.
there are two.
Yes.
What?
Have you ever seen Despicable Me?
Oh, yes.
You say no, it doesn't make any sense.
No, it should be.
Okay, moving on. Hold on. I got one more. Before I forget my metaphor, hold on. And I forget the names, who goes with what. Okay. Biff is Russian. Here comes Biff. Here comes Pancake Man. Hello, I'm Pancake Man. I'm a radical. No, I'm Biff. I'm your doom. Now, I understood you fought a square root the other day. That is correct. Why you bring this up? Well, that was my brother, and I'm here for revenge. This be funny, yes. So now, Radical is only half as strong as the brother that was evenly matched. So what's really going to happen is, all right, I demand satisfaction. Pancake Man, Radical, put up your dukes. Very well, I put up dukes. I put down dukes. Pancake. So, not a fair fight. Now, if there's not a fair fight, chances are the law is going to get involved somehow. Yeah, we understand you just pancaked this fellow and you're way stronger than he is. I'm sorry, I'm going to have to arrest you and bring you to the station. It is a fair fight. Okay, so.
It's all being filmed.
Now, why do I do the stupid metaphors when I'm on film? Sorry. Okay, next week this time you'll have me herding goats in Madagascar. And somebody else will be teaching. I will be quietly moved away as Mr. Maltby makes an announcement to the faculty and staff. I'm terribly sorry. Mr.
Well,
Maltby
Sister Mary Daniel, please.
decided that this wasn't for me. Moving on. Now, why do I bring this up? Whenever you have an unfair fight, everybody see why this is unfair?
No.
There's no plus minus. Plus minus makes it twice as strong. Like, here. This is strong.
Strongo.
This is weak.
We go.
They kind of do the same thing. Like you hit the square root button on the calculator. It's actually a radical button on the calculator, believe it or not. We just don't want to freak out fourth graders when you say, that's a square root. They're still like, what's a square root? I'm so confused. They don't want to hear the word radical. It'll just make things totally
I don't want to hear it either.
Now, there is a price to pay for an unfair fight. All solutions. Hold on a second. And you might want to write this down. With all this blah, 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 you don't have to write all of it down. This thing here. When you're squaring a radical, not a square root, so to say, not plus minus. So it's not plus minus. It was just a plain old radical and you're squaring it. That's called an unfair fight, and there's a price to pay. All solutions have, and I'm not kidding you, a 50% chance of being wrong. In other words, you must test them all. Oh no. An unfair fight has a price to pay. That means that if you have an unfair fight, you can solve it, but every single solution has a 50% chance of being wrong, and you have to test it to see if it's right or wrong. Let me erase some of this stuff, I'll show you. Over yonder, we got two solutions, x is 2 and x is 7. The restrictions were fine with them. It just said anything bigger than or equal to negative 2. Well, both of them are greater than or equal to negative 2. We're good on that. So x equals 2 x equals 7, and here's the formula that came from. Radical x plus 2 is equal to x minus 4. What does it say to do in an unfair fight?
That's all.
You have to test both of these and see if they work. How do you test it? Yeah.
Just plug them in.
Plug them in. Now remember, there are 2 slots for x. You gotta plug them in twice. So it'll be radical 2 plus 2 is equal to 2 minus 4. Try that for me. Who's feeling brave? Go. Radical what?
That's wrong. Radical 2, 4.
4. Very good. Equals what?
Negative 2.
What's radical 4?
2.
So what do you think?
It's wrong.
That's wrong.
2.
X equals 2 was false. We didn't know that until we tested it. If it's false, you have to throw it away.
Hey,
How about 7? Yeah,
it's wrong.
try it. Radical 7 plus 2, is that equal to 7 minus 4?
Yes.
What's this going to give you?
Radical 9.
Radical 9 equals 3. As a matter of fact, that one's good. So in other words, this is the only solution that works. You did get one, congratulations. I have run into problems where both of them fail. It's rare, but it does happen. And I have run into problems where both of them work. But usually, like 50-60% of the time, one of the two of them fail, and one of the two of them succeed. Yeah.
What do you do if both of them fail?
What do you do if both of them fail? Then you write the words, no solution. And by the way, let me just say it again as sort of an infomercial. Once I introduce the idea of no solution, there are some people, like in Algebra 2, they just write that for everything. They said, this problem is hard. No solution!
That's
No.
what we do with prime.
It's like, yeah, exactly, it's prime. It's like, everything is prime because it's tough. So no, you can do magic pair. I hate magic pair, it's prime. No. That's not the point. Prime means it cannot be done ever.
To give us something.
Not even by God, because it's impossible. So, but that's not here with you. Yeah. I'll have to give you this philosophy talk sometime. We have 5 minutes.
Yeah, of course. Please, 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 please.
Don't get used to that.
It's the first day.
That's the matter, it's the first year of school. Thank you, old lawyers. Yes, you are correct, there's no homework for tomorrow. Don't get used to it.
I used
No.
to it.
There will be homework tomorrow, or due for Wednesday. Okay, in payment for that, I want you to think about this. And by the way, if this keeps you up at night, I apologize.
What?
But
Oh.
can you name something that God cannot do?
No.
Yes.
Go.
No.
Sin.
Oh.
Oh, that's good.
Deceit.
Oh, yeah.
What?
He can't lie.
He can't lie.
That's
it.
it.
That's
Deceit.
it.
But like,
Yeah,
obviously, but I'm saying like.
He cannot make a mistake.
Oh,
Yeah.
you cannot die.
He cannot die.
Well, yeah.
You cannot use the bathroom.
Not even going there. Yes, he can. Okay, but here's a quick question.
You did.
Can God create a married bachelor?
Yes.
No. Yes.
Let me know what a bachelor is.
Yeah.
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 It's an unmarried man.
Yeah. Contradiction.
Exactly. So can God do it?
No.
No, it's a contradiction. He can contradict himself.
What?
Correct. The answer is no.
Yay.
God cannot create a married bachelor. Question number 2.
Bachelor.
Well, actually, that's the question
Can,
number.
yeah, we won't be a bachelor anymore. Can God create a square circle?
Yes.
No.
No.
Two different things.
Right. It's contradiction. This one's a little harder to tell.
What's contradiction?
Can God, a contradiction means two things that can't be true at the same time. In other words, if somebody said, my first name is Brian, which by the way is true, and my first name is not Brian. Wait.
Good morning, not Brian.
So which is it? Yeah. But I can't be both at the same time.
Not Brian. It could be like the answer Brian.
Like my brother's name is not Brian, it's Dan. But he can't be Brian and Dan first name at the same time. He could have a second name of, or a hyphen or
Well,
something.
what if your name was Brian Day?
Yeah.
What if your name
And
was
that wouldn't be Dan, that would be Brian.
Brian, not Brian?
Clear? Now listen up, real fast.
Okay.
Can God create a stone First of all, can God create rocks? Absolutely, he did it all the time. Can God create a stone so heavy? He can create really heavy stones, right? Can he create a stone so heavy that not even he can lift it?
No.
No.
Wait,
Isn't that a limitation on God then?
wait, what?
Wait,
That is a.
I gotta get the expression in my face.
wait. The stone so heavy that he can't, well, that
And
doesn't
if
make
you can't
sense.
lift it, then.
Exactly. It is a hidden contradiction,
Yeah.
which basically means to say that God can create a stone so heavy that not even he can lift it, that means that God can exceed God. And that doesn't work. Can God become greater than God? No, because God is infinitely
It's
big.
like eating your own
You
record.
can't get any bigger. So,
Like what?
Eating your record you gave.
God cannot do the impossible. That doesn't mean there's any limitation on God.
Oh, yeah.
Let me give you an example. Question. I have had atheists come to me in college with this sort of stuff. And thinking, well, you said your God was omnipotent, all-powerful. Haha, I just showed his mouth. And I said, oh, haha, you just talked to a math major. Sit down, son, let me school you. And I didn't say that. I was trying to be a little more polite. But they said, okay, let's turn this into a math problem. Lots and lots of things God can do, right?
Why did you wanna do that?
I don't know. I was bored.
You're bored.
And I also, there are also the people listening, so I want to make sure they don't. Okay, we need to go over this a second. Listen carefully.
We still have 2 minutes.
So, question. Good question. I know
What
that.
question the church is ready to,
Right.
for us to leave?
Listen. Suppose I said, well, there's lots of things in the world God can do.
Yeah.
How many married bachelors are there?
None.
None. So if you take away all the married bachelors, what have you taken away from what God can do?
None.
Nothing. Take away all the contradictions, how much have you taken away from God?
None.
0. If you have infinity minus 0, last time I checked, that's infinity. You have taken nothing away from God by saying he cannot do the impossible. Here's one last thing, philosophy question.
Okay.
Can God believably squirt?
Wait, what?
Good answer. Can God believably squirt?
Yes.
Yes.
Yes, you guys need to.
You need to ask a question before you answer that.
Can you repeat that? I don't know what you said.
Can God believably squirt?
Legally? Sure he can.
It's a meaningless thing, I just made it up.
You mean like in soccer?
I just thrown a bunch of syllables together. No, it's not.
Oh, you can score?
I will say this much, can God believably squirt? And the answer is no, because there is no such thing. I made it up.
Totally do that.
It's totally non-existent. By the way, if you take a non-existent thing away from God, how much have you diminished him?
No.
No. Ta-da. There you go.
Okay.
Please stand. Let's pray. Freeze. Freeze, y'all. Prayer before academics. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Glory be to the Father, to the Son, and to the Holy Spirit. As it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and of the Son, and of the Holy
Hey
Spirit.
guys, we're
Okay, people listening at home, thank you. Talk to you later. Bye.